In 1968, workers clearing dirt from a collapsed rock shelter on a Montana ranch struck something unprecedented. Bones stained red with ochre lay beside more than 100 stone tools. A toddler, 12,600 years old, the only Clovis burial ever found. For decades, those remains sat in storage while a fierce debate raged. Did the first Americans descend from Siberia or from Ice Age Europe? The answer was locked inside that child's DNA. On a windswept bluff in Montana's Shields River Valley, a shallow rock shelter once overlooked the movements of Ice Age hunters. In 1968, as earth was scraped away from a collapsed outcrop on the Anzac family ranch, a cascade of ancient objects tumbled into view, more than 100 stone and antler tools, everyone stained deep red with powdered ochre. Beneath this dense cache lay the tiny, fragmented bones of a child. The site would be catalogued as 24 PA 506, its location fixed by field notes and GPS coordinates, but nothing else about it was ordinary. Archaeologists counted at least 90 artifacts at first, later revised to over 115. There were fluted Clovis spear points, some reaching 12 centimeters, shaped for the hunt and unmistakable in their craftsmanship. Bifacial scrapers, heat-treated for strength, lay beside antler rods and bone beads, each piece deliberately placed, each one marked by the same vivid ochre pigment. The ochre soaked not just the tools, but the child's skull and vertebrae, forming a thin, ritual coating that echoed burials from the Upper Paleolithic. This was not a haphazard grave, it was a carefully prepared interment, the only one ever found that links human remains directly to a full Clovis toolkit. Radiocarbon dating of bone collagen and antler rods fixed the burial at around 12,600 years before present, making these the oldest human remains ever unearthed in North America. The tools and bones were sealed together in a discrete layer of fine loess, undisturbed by later occupation or animal burrow. No other Clovis site, from Blackwater Draw to Murray Springs, has yielded a burial like this. Most are simply kill sites or tool caches. Here, the physical evidence spoke of a culture's care for its young and of beliefs carried across millennia. Yet, even as the artifacts were logged and the bones archived at the Museum of the Rockies, a single question lingered unanswered. Who were these people, and where did they come from? Across the Atlantic, a different theory was gathering momentum. In the early 2000s, Dennis Stanford of the Smithsonian and Bruce Bradley of the University of Exeter challenged the idea that the first Americans came solely from Siberia. They argued that the fluted spear points of Clovis culture looked strikingly similar to stone tools made by the Solutrean people of Ice Age France and Spain, dating from 22,000 to 17,000 years ago. Their book, Across Atlantic Ice, described a scenario where Solutrean hunters, following the edge of the glacial pack ice, paddled along the North Atlantic and reached the Americas thousands of years before the Beringian migration. The claim rested on the physical resemblance between Solutrean leaf-shaped blades and Clovis points, the careful thinning and fluting, and the expert pressure flaking. To Stanford and Bradley, these were more than coincidences. They saw a technological fingerprint, a direct link that crossed an ocean and a continent. But the evidence was thin. No archaeological sites have been found along the supposed Atlantic route. No campsites, no middens, no transitional toolkits bridging the gap between Europe and North America. The last Solutrean sites in Spain and France are at least 4,000 years older than the earliest Clovis horizon in Montana. Most striking of all, every genetic study of ancient American remains, at least until Anzac, had failed to find any trace of European ancestry. The Atlantic model, bold as it was, had no genetic anchor. Without a Clovis genome, the debate was left to stone and speculation. As the arguments sharpened, the bones and ochre-stained tools from Montana waited in museum storage, silent witnesses to a controversy that only DNA could resolve. The Anzac child, by fate or accident, had become the only possible genetic witness for the Clovis people. Sarah Anzac grew up with the weight of history in her family attic. The ochre-stained bones of the Anzac child, boxed and silent, were not just objects of scientific curiosity, they were a presence in her childhood home, a reminder that the past was never far away. By the time she became a molecular biologist, Sarah was acutely aware that these remains were more than data points or museum specimens. They were someone's child, and they belonged to a living story still unfolding in the valleys of Montana. The legal landscape had shifted dramatically since the bones were first unearthed. In 1990, the Native American Graves Protection and Repatriation Act, NGPRA, established new rules for how ancient remains should be treated, requiring museums and researchers to consult with tribes before any study and to return ancestors when cultural ties could be shown. But NAGPRA did not reach onto private land, and the Anzac burial, discovered on the family ranch, remained in a gray zone. The memory of Kennewick Man loomed large. After years of courtroom battles, the courts had ruled in 2004 that ancient remains could be affiliated with living tribes through DNA, not just artifacts or oral history. That decision led to the reburial of Kennewick Man in 2017, but it also left a lesson. Science could not move forward without tribal voices at the table. When Sarah was approached to allow DNA sampling from the Anzac child, she refused to act alone. She reached out to the Crow, Northern Cheyenne, and Lakota nations, inviting their leaders into the decision. She explained the scientific promise, but also the risks of disturbing a sacred burial. The discussions were careful, sometimes tense. Only after tribal representatives gave their consent did Sarah authorize the removal of a tiny bone fragment for sequencing. In that act, she set a new standard, one where the pursuit of knowledge would not come at the expense of respect, and where the story of the first Americans would be told with the blessing of their descendants. In Eske Villerslev's Copenhagen laboratory, the ancient bones of Anzac one entered a world designed to keep the present at bay. Every surface was scrubbed with bleach, every instrument blasted with ultraviolet light, and the air itself filtered to remove the faintest trace of modern DNA. The stakes were unmistakable. A single errant cell or a careless breath could erase the line between ancient and contemporary, turning a genome 12,600 years old into a muddle of contamination. Sarah Anzac and Willerslev's team worked with fragments from the child's lower jaw and a tiny molar. These samples, protected through decades of careful curation, now faced a battery of protocols meant for the most fragile remains. Bone powder was drawn in small increments. Each extraction performed in a clean room where laboratory coats, gloves, and masks were as much armor as attire. The lab's workflow, refined through years of ancient DNA work, included duplicate extractions and repeated negative controls to ensure that no modern DNA slipped in unnoticed. Once the DNA was isolated, it was prepared for sequencing on the Illumina HiSec 2500, a platform capable of reading billions of genetic fragments at once. The Anzac 1 genome achieved an average coverage of 14.4 times, meaning every letter in the child's DNA was read, on average, more than 14 times. This depth allowed the scientists to distinguish ancient genetic signatures from the characteristic damage that accumulates over millennia. Cytosine bases, for example, often mutate to thymine at the ends of ancient DNA strands, leaving a molecular fingerprint of age. Strict authentication steps confirmed the material's authenticity. Damage patterns matched expectations for remains of this antiquity, and contamination estimates calculated from mitochondrial DNA and nuclear markers fell below 1%. The child's mitochondrial lineage, identified as D4H3A, was rare but unmistakably ancient, ruling out the possibility that the DNA belonged to any modern handler. Every safeguard, every redundant check, built confidence that the data reflected the true genetic story of the only known Clovis burial. With the raw sequence in hand, the team prepared to ask the question that had haunted American archaeology for decades: where did the first Americans come from? Statistical analysis began with principal component analysis, projecting the Anzac 1 genome against panels of global populations. The result was immediate and unmistakable. The child's DNA clustered tightly with modern Native American groups, not with Europeans or East Asians. F-statistics, a set of tools that measure shared genetic drift, revealed an even deeper connection. Anzac 1 shared more alleles with indigenous peoples across both North and South America than with any Old World population. Yet the genome also carried a distinct signal, a thread of ancestry linking the child to a 24,000-year-old individual from Malta near Lake Baikal in Siberia. This Malta signal, present in all Native Americans but absent in Europeans, pointed to a Siberian source for the founding population. No evidence of European admixture appeared, even at the margins of detection. The verdict was clear: the genetic legacy of Clovis, embodied in the Anzac child, runs through the first peoples of the Americas and back to ancient Siberia. No trace of European ancestry surfaced in the Anzac 1 genome. Genome-wide analyses placed the child's DNA squarely among Native Americans, with admixture models showing less than 2% of any possible European contribution, an amount indistinguishable from statistical noise. The Nature paper's authors wrote that the genome shows unequivocal Beringian origin, closing the door on the Atlantic crossing theory. Every test, including admixture, F statistics, and QPADM, returned the same verdict. Clovis people did not descend from Ice Age Europeans. The Solitrian hypothesis, once debated in conference halls and books, could not withstand the genetic evidence. With this result, the idea of a European origin for Clovis was decisively set aside, allowing the story of America's first peoples to return to its true roots. Today, the Anzac child's DNA stands as both scientific proof and sacred testament, confirming what tribal nations had always known. These are our ancestors' remains, not artifacts. As debates rage over land, identity, and history, the real question is whether we will finally listen to those whose story began here.